Hey calculus kids, this is Dr. Callahan with week 18 Monday. How are you guys doing? I hope you guys had a wonderful weekend. Go ahead and take a look at the following questions and answer this on your warm-up log for week 18 Monday. All right, let's go ahead and get started for today's stuff. So as you guys know, this is our last week before your AP exam for 2021. And if you guys take a look at this part right here, your focus for this week is specifically just going to be on the last practice exam, which is practice test exam 2. It's 51 questions on Albert IO. So make sure you guys are completing this by Friday, or excuse me, by Sunday of week 18. So right now we are right here with the 17th of May. Your test next week is going to be on the 24th, 8 a.m. in the Career Center. Make sure you guys have your TI-84 calculators readily available with you guys. And if you're interested in going over any of the free response questions, we have actually gone over several in this class, and that started back then this is week 18, so that would have been like week 14, Monday, all the way to week 17, Friday, that we have gone over different types of free response questions. So this week, what I'm going to be doing is a little bit different. We're done kind of focusing on the free response questions. This week, I would actually like to focus on the multiple choice questions and starting off with limits. Then we're going to go into derivatives, and then from there, applications of derivatives like extrema, concavity, and then starting with integrals, and then different techniques of integrating integrals, and then the last unit, which is going to be applications of integrals with areas and also volume. So that's kind of what we're going to be focusing on for this week. I felt like we did enough when it comes to free response. Keep in mind that there are 2 sections of free response, with a calculator, without a calculator, 2 questions with a without a calculator. 2 with a calculator, 15 minutes a piece. 4 without a calculators, 15 minutes a piece as well. So this week, I would like to focus a little bit more on your multiple choice questions. And like I said, we're going to start off with limits today, and then tomorrow we're going on to derivatives. So this is your guided notes for today. So if you have it with you, this is kind of what it looks like. If you don't have a copy of this with you, that's okay. You could just kind of practice it along on a separate piece of paper. That's completely fine. All right, so let's go ahead and get started. First things first, read the definition of what a limit does. Right here. And we'll go through some practice problems, because even though the multiple choice or the free response questions are really important, so are the multiple choice. Multiple choice are going to be worth the other 50% of your test. All right, question number 1. What is the y value or f of x value as x approaches -3? So here's your -3 as x approaches -3 on the left side. Get a test it from the left side. It looks like it's at -3. And then when it approaches from the right side, I'm sorry, it's not -3, 2. Duh, sorry, I'm like doing the wrong part. Right side, it is 2. So given the fact that both of these are consistent, you can say that it is 2. Question number 2, f of -3. So this is not a limit. It's saying when x is equal to -3, what is the y value? So at -3, the y value is at 1. For number 3, what is x as what is the function as limit approaches x -3 from the left side? So if approaching -3 from the left side, it looks like it's at 2. And from the right side, it's at 2. Question number 5, what is your function as x approaches 0? So you can start from the left and then from the right. From the left, here is 0. From the left, it looks like it is kind of at 1, or maybe a little bit below 1, like, I don't know, like 0.9 or something. And then as it approaches from the right side, if you look at it, it is at 2. Given the fact that these two are not consistent, your answer does not exist. For number 6, it's saying when x is equal to 0, what is your y value? So when x is equal to 0, your only value that's available is at 2. That's solid dot. Question number 7. As x approaches 0 from the left side, your answer is going to be like around 0.9 or 0.8. Or it's less than 1, I should say. For 8, as x is approaching from the right side, it is at 2. For 9, as x is approaching to 2, you got to check it from the left side and the right side. So if it's approaching 2 on the left side, the y value is at 1. As it is approaching from the right side, right here, the y value, it's also at 1. So I could consistently say that because these two are consistent, it is at 1. For number 10, as x equals 2, so what is my y value? It is 1. So notice a difference here. For as x approaches 2 and f of 2, this is a continuous function. It's a continuous function because as it's approaching from the left, it is equal to 2. 1, as it's approaching from the right, it's equal to 1. And 1 is exactly at 2, it is equal to 1. So it's check, check, and check. So this one is continuous. This one here, because it's a check, check, but it's not a check here, this is actually discontinuous. It's a discontinuous limit. Okay, now let's go on to the next part, evaluating limits algebraically. I would like you guys to go ahead and read this part on your own, and we'll go over some examples. Okay, so for number 1, you should always do direct substitution, so as x equals 3, and you should eventually see that if you do direct substitution, what's going to end up happening is that 3 times 3 is a 9, 2 times 3 is a 6, minus 3, that's going to give you a 0. You can't have a 0 in the denominator because it does not exist. So this is where algebra comes in, because hopefully we can factor it out. And you cancel something in the denominator to eliminate it from resulting in a 0 in the denominator. So x minus 3, x plus 1. Sorry, let's see what happened here. Let's try that one more time. Okay, so then looking at this part cancels. I have 1 over x plus 1. Now let's try direct substitution one more time as x approaches 3. So 3 plus 1 is a 4. So I can say that my answer is 1 over 4. Number 2, direct substitution, as you can see, is going to result in a negative 3 plus 3, which is a 0, so that's not good. So let's go ahead and see if we can factor something out. In this situation, I can't factor anything out, but what I can do is, because it is approaching negative 3 from the left side, then I can say that if it's approaching from the left side, it could be a negative 3.01. Okay, so 2 times negative 3.01 plus 1 divided by negative 3.01 plus 3. If you plug that into your calculator, you will get, on top it's a negative 6 plus 1, which is also just going to result in like a negative. In the denominator, it's a negative 3.01 plus 3, so it's a negative 0.01, and notice it's a very small number. When we have a bigger number divided by a very small number, what's going to end up happening is it's going to get to a really big number, so it is going to be approaching infinity. All right, so as x is approaching the negative infinity, remember this is the one where you have to look at the horizontal asymptote, and it results with the 3 different rules. Remember, if you have like x squared over x1, where it's bigger on top and then small on the bottom, x squared over 3x squared, and then remember there was one that was, oh, you know what, I have it right here actually, so fairly simple to go by right here. Limit of 0. If the numerator is equal to the denominator, then it's going to be the ratio of the coefficient. If the numerator is bigger than the denominator, then it does not exist. Okay, remember that rule. So looking at this here, I have the biggest one is at 1x squared. Biggest one here is negative 5x squared. They both have squares, so it's just the coefficient, so negative 1 over 5. is your answer. All right, let's take a look at number 4. For number 4, if I go ahead and do direct substitution, I will have sine of 0, which is 0. And then I have ln 2e to the 0 minus 1. This part is just going to give me a 1. ln 2 times 1 is just ln 2. But then that 2 minus 1 is going to be ln 1, which is going to be a 0 over 0. So that's not going to help me. So what that means is that I want to go ahead and rewrite this. So what I can do is another way of saying the limit as x is approaching 0 is, instead of putting a sine, we could do a cosine over your ln 2e to the x minus 1 is going to be the same thing as 2e to the x over 2e to the x minus 1. So then as I plug in the 0 for this, I'm going to have cosine of x, which is cosine of 0, is going to be a 1. E to the 0 is 1. 1 times 2 is just 2. Same thing here. E to the 0 is 1. 1 times 2 is 2. 2 minus 1 is just 1. So I'm going to have a 1/2. And if you're curious as to how we got from this part here to this part here, remember Algebra 2 Honors, you guys had the different ways you can rewrite ln. So if you have ln x minus y, that's the same thing as x divided by y. Okay, let's go over to the continuity conditions. All right, go ahead and read these 3 theorems that we've gone over. Example 1. So the function of f is defined by f of x square root of 25 minus x squared in between -5 and +5. And then you have a piecewise function over here. So it says, is g continuous at x equals -3? Use the definition of continuity to explain your answer. So then looking at this right here, you can say that g of -3 is equal to f of -3, which is going to be equal to, so when x is -3, it's going to be this equation here, which is this part right here, square root of 25 minus -3 squared, which is equal to the square root of 25 plus 9, which is going to be, or I'm sorry, not plus 9, minus 9, because -3 times -3 is a positive 9, positive times a negative is a -9, square root of 16, which is going to be 4. That's the first part. The second part to this is I have to check for, remember you have to do when x is exactly at -3, as a limit approaches 3 from the -3 from the left side, and then as x approaches -3 from the right side. So let's do the second condition, okay? So the second condition is you're approaching this from the left and right side. So then looking at this here, what is my limit as x approaches -3 from the left side? So I have a square root of, it's going to be -3 from the left side, it's still going to be between -5 and -3. So 25 minus -3 squared, which is still going to give me 4. Now, second part is a limit as x approaches -3 from the right side, which is going to equal to this equation right here. So x plus 7, which is -3 plus 7, which is still 4. And they're the same, so that's good. Now the third equation is going to be the limit as x approaches c, f of x equals f of c. So for that one, I'm going to say that g of -3 is going to have to equal to the limit as x approaches 3, -3, g of x. And guess what? When I approach it from the left and right, left equals right, which is going to be a 4. So that checks out. So given the fact that we met these 4 conditions, given that we met these 3 conditions, g of x is continuous at x equals 3, -3. Sorry, keep thinking that's positive 3, it's a -3. All right, guys. Let's take a look at this one here. If the function f is continuous for all real numbers, if f of x is x squared minus 4 over x plus 2, where x cannot equal -2, then f of -2 is going to equal to, and again, you want to meet those 3 conditions. First condition is f of -2. What is that going to equal to you? Second condition is a limit as x approaches -2, you have x squared minus 4 over x plus 2. So if I plug in -2, I know I'm going to get a 0 in the denominator, which does not exist. However, if I go ahead then use out analytically to factor this out, x plus 2, x minus 2 over x plus 2, x plus 2 cancels, and then guess what? I have x minus 2 on top, so then -2 minus 2 is -4. The third condition that I have on your paper is that f of equals -2. What is the limit as x approaches -2 for f of x? And it equals -4, okay? So therefore, f of -2 also equals -4. So -4 is going to be my answer. Okay, next that we talked about is going to be the intermediate value theorem, IVT. So let f be continuous function on the closed interval -3 and 6. If f of -3 equals -1, f of 6 equals 3, then the intermediate value theorem guarantees that it is going to guarantee you for D, f of c equals 1 for at least one value, there is going to be a c that is going to be between -3 and 6, where that slope is going to be equal to the slope formula itself of whatever this result with. And that is your answer. All right, you guys, I'm going to have you guys go ahead and flip over this to the back of this paper. If you cannot see that at home, it looks like this here. So I would suggest that you guys practice this with a little bit. And then, of course, if you're ready for the steps and answers, here is the URL and the QR code. And if you go ahead and type that in or click on it, that does not make me feel good about that. If you go ahead and do that, it is going to take you over to, let's try this one more time. I'm just going to say that if you're having difficulty finding that, or that QR code is not working, which I don't know why it's not, but if it's not, just Google Dr. Natalia Callahan. From there, go to the webpage. You want to go to Calculus Spring because we're in the spring semester. go down to week 18. We're out of space, so click on this one more link. And then once you get there, it's going to be the AP topic practice. If you click on the one above that, it will give you guys the answer for the ones that we just went through. But of course, this is the one that we are not going over. It's this one right here, practice. So click on that, and it'll give you the answers for the practice. Okay. So that's one way that you can access that. Another thing that I have here on your guided note is the part down here. Okay, so this is the actual AP exam of 2012 with the multiple choice questions. So I want you guys to go ahead and take a look at the blank version of that, and here's your QR code for it. And when you guys are taking a look at that, and again, I don't know what's wrong with the link. Maybe there's something just weird about it. In which case, that's okay, because you guys can go ahead and go back to this page here. You're going to go to the AP practice exam. Click on that. And actually, that gives the answer. So we want the one below that. This is the actual exam itself. So I would suggest that you take a look at it, get yourself acquainted with it. Chances are your test will look very similar to this. The wording might be a little bit different, but it should be somewhat similar in the organization of it, just so you guys get acquainted with it. And then take a look at some of the questions that they have here. You have to scroll down quite a bit, where it says multiple choice section, 2012, and then so on and so forth. And this is where it generally starts. Okay. Okay, and so these are the questions. They obviously use a lot of paper on this because they're wasting a lot of paper. I didn't print out for you guys because this one, I believe it's like 86 pages. So I didn't think it was necessary. Let's just try to save a tree so we don't do that. And so then if you guys need the answers for it, the answer is going to be right here where it says solutions with this QR code. So let's go ahead and take a look over here. So if you want the answers, it's going to be the first one right up here. Click on that. And then here are your answers for all of the questions on that exam. All of the multiple choice ones anyways. So you can just take a look at that. All right, you guys, as always, I hope you have a wonderful week, and I'll see you guys next time. Take care.